So in this short video, we'll just be recapping some SI units. So the SI unit is the Système International, and it's the standard for units of physical quantities. This international system of units is based on the following 7 base units. 1, the metre, which has got the symbol lowercase m. 2, a kilogram, lowercase kg. 3, the second, lowercase s. 4, the ampere, uppercase A. 5, the Kelvin, uppercase K. 6, the candela, lowercase cd. And 7, the mole, lowercase mol. Other SI units, e.g. the joule or the Newton, are called derived units, and they are defined in terms of base units. You need to be able to convert the derived units into base units. So looking at the table here, time is measured in seconds, symbol S. Length measured in meters, symbol M. Amount of substance, moles, symbol MOL. Mass, unit kilogram, symbol kg. Current, ampere. Temperature, Kelvin. Light intensity, candela. As a rule of thumb, in any physics problem, what you should be doing is, if the question is given in terms of derived units, then you should attempt to convert them into the base units. It's not always practical, and some of the base units are sometimes more practical to use, are often more practical to use than these SI base units. But at higher level school physics, so higher level GCSE and into AS A level, you need to be able to convert between those, and you also need to be able to express derived units in terms of their base units, SI base units. So in physics we deal with both very large and very small numbers. So to make it easier to write these numbers, we use prefixes, and you need to be able to identify common prefixes and understand what they represent. So these need to be learned, and what you really need to know is not necessarily the prefix here, but you need to know the symbol and how it relates to what factor, what power of 10 it means. So the most common ones are all the way from giga down to micro. So if you see any of those ones, you need to know what those are. So for example, you need to know what this symbol here, this Greek mu, that's the Greek letter mu, you need to know that that refers to 10 to the minus 6. So for example, 12 gigameters is 12 times 10 to the 9 meters, which is 12 billion meters. 7 milliseconds, and note that it's written with the unit, there's no space between the M and the S. If there was a space between the M and the S, that would mean that it would be meters multiplied by seconds, which is completely different to milliseconds. So that's something to watch out for. So 7 milliseconds is 7 times 10 to the minus 3 seconds, which is 0.007 seconds. 473 nanograms is 473 times 10 to the minus 9 grams, which written out is this. So if we have a look at some practice questions here, we convert the following to base units. We'd have 250 gigameters is 2.5 times 10 to the 11 meters. That could be written as 250 times 10 to the 9 meters, but in standard form you only have a maximum of 1 digit in front of the decimal place, in front of the decimal point. 360 millimeters is 0.36 meters. 475 kilometers, 4.75 times 10 to the 5 meters. 7,000 nanometers, 7 times 10 to the minus 6 meters,